In this video, I start the process of migrating the register design from the breadboard into KiCad. And I start doing this by moving the bus output controls, the line drivers, into KiCad. Hi, my name is Adam. I'm building a 16-bit computer from scratch. I hope you'll join me on this journey. While I'm getting the KiCad project set up, let me tell you a little bit about some of the decisions I've made about how I want to organize these videos. The video playback is going to be at 2x speed, and I'm going to do voiceovers over the top of that. I think that strikes a very good balance between presenting the content and not making everybody sick watching the screen, because the movements can be crazy. I'm also making an effort not to zoom and drag around and focus in on a single area at a time, so hopefully that will help as well. The first thing I chose to start with was the line drivers for outputting to the different buses, and specifically address bus 1. No particular reason to start there other than the fact that it's in the upper left-hand corner of the breadboards. Those are built off of the 74LS541 chips, and so I go find those in the library repository and drop a couple of those onto the schematic. That then allows me to get those lined up and start filling in the connections. As I work on adding power and ground to these two integrated circuits, take a note that the layout of the 74LS541 in the schematic conceptually does not match the physical layout in reality. Right now we're working on a schematic, not a PCB layout. For the PCB layout to take place, I've got to get the schematic correct. So you'll see things like pin 1 and pin 19 sitting next to each other when in reality they're not. I'm trying to figure out how to change the name of ground ref to ground, and I am not able to figure out how to do that. And now I'm trying to move the ground lines down a little bit just to make it in a little extra room for some of the bus connections that I'm going to add in. On the breadboard, I tied pin 1 directly to ground. I'll do the same here. Next, I have the 16 input connections into these line drivers, which are the contents of the register itself. I need 16 of those, and I chose to number those from 0 to F using a single hexadecimal digit. Call me crazy, but I'm a programmer at heart anyway. It takes a couple of minutes to get those laid out and then rename each of those connections. I'm trying to find a pane that I can use to edit the names of each of those connections in turn without having to open up a dialog box. I can't find one. The next step is to create the 16 output bus connections. Notice I select output. And again, I will number those from 0 to F, a single hexadecimal digit. This is address bus 1, so these are appropriately named. I got smart here and used copy and paste after I had more than one of the bus connections in place, so that I didn't have to paste each one individually. Finally, a little bit of cleanup just to make sure everything lines up properly. I know there's a way to move components around while still keeping all the connections intact. I believe I was using move in the video, and now thinking about this during the voiceover, I think there's a grab option I should have been using instead, which would have adjusted all connections at the same time, allowing me to go back and clean those up easily. More easily, I should say. I'll have to give that a try the next video. I definitely had a tough time deleting this little segment. The final order of business here is to wire up the control lines needed to assert the values of the register onto address bus 1. With that complete, what comes next is quite a bit of copy and paste. Stick around to the end because there are some issues that I do want to discuss before the video itself is over. But second first, same as the first. Renaming the control lines. Renaming the bus outputs. Now for ALU-A, I start with the bus outputs. I do come back around to pick up the control line names later. ALUB, and again the bus outputs first. Now I circle back and take care of the control signal names. One final copy and paste to gather the main bus output and the byte swapped main bus output. Stay tuned, there will be some trouble. Since the layout doesn't fit on a page, I decided to stagger them a little bit like a stair-step pattern. And so I cleaned that up real quick. Second verse, same as the first. Now it's time to rename all the main bus outputs to conform to the naming convention. Plus the main bus output control line. Now here is where the rote repetition of copy and paste and update the labels starts to catch me here. I start by renaming all of the outputs to be a swapped main bus output or a swapped byte bus output when there's really no such thing. They all need to be output to the same bus. Now I do get the control lines right. And then I go back and hide all the ground ref labels. Now, after stopping the recording and staring at my accomplishment for a few minutes, I realized that I need to swap the order of the outputs for the swapped byte main bus output. Still not quite right, but I go about getting that accomplished. And then again, after stopping the recording and staring at my accomplishments, I then realized that there's no such thing as a swapped bus, and relabel everything appropriately now for the main bus in the correct sequence. Before I wrap up, I want to talk real quick about the elephant that's still in the room. When I put these ICs on the schematic, I put down 74LS541 line driver chips. And I've said that when I go to make the breadboards, I've said when I go to make the PCBs, I want to use 74AHC. Make sure I get those letters in the right sequence. 74AHC ICs. These are going to be advanced high-speed CMOS. And so if I'm looking at KiCad to output a bill of material for me, it's actually going to be outputting the wrong thing. Now, I can likely leave them like that and know that I need to just order the correct thing after it's been output. But my OCD won't allow me to do that. So I do need to go and change these ICs to be 74AHC series. But the problem is KiCad doesn't have those available to me. So I now have to make a copy of a 74LS to be a 74AHC, and then go in and rename all of these components that are on this drawing. I'm not going to do that now. I'll do that in the next video. So, as I just mentioned, I need to create the 74AHC 541 IC in KiCad and make those changes so that I'm using that new IC versus the 74LS. And I have more work to do on the register circuit design, migrating that into KiCad. I'm more than likely going to work on getting the register and its output migrated in the next video as well. Plus, I've got my other to-dos that are still sitting out here. I don't want to lose track of those, so I have things to do for the clock, for the control, and pretty quick coming up here, I do want to define what the opcodes and operations are actually going to look like so that we have some context for other things that we're going to build. And then I discovered I needed to add a line driver to the bus input test harness. Thank you. We'll see you soon.